Hello, we are going to show you the use case of Studio4Education. This is an educational tools we made with the help of different partners, and this is an educational tools and also something for beginners in the Arrowhead tool service. The part of the Studio4Education is based on the Blockly framework developed by Google, and then is used in many projects for the last 10 years. This is a visual programming language that could help everybody to create an algorithm, as you can see in this example. Every block stacks on the others, and then it's translated in a language. You have to create your own language generator, but the first demo from Blockly team is able to translate into JavaScript, Python, or something, any language without typing, in fact. And so it's a worldwide used framework to create games or mathematics program to resolve, or other project to program microcontrollers. And then the other part is to create a toolchain, because Blockly is the art of Studio4Education, and then it keeps information from Papyrus and then send the program into STboard. So the STboard is a worldwide used microcontrollers in many professional cases, and what we are testing is the STM32 Nucleo. It's very simple board to test and prototype. So our use case starts with the use of Papyrus to model the system, and then the information are sent through Arrowhead tools to Studio4Education, because it's permits to set up Studio4Education for the pupils, the students, and then students are creating their program, and it's sent to the STboards. And through Arrowhead tools, we also can get back data from the sensors or control actuators. So this is the idea: is to have an idea that can be modeled by Papyrus, and then we create the algorithm, and then it's translated into a language that can be uploaded into the microcontroller. So now in details, the different software will be shown, and then you will see it in action. But first, the first step is the use of the Papyrus software to model the ideas, and it's software developed by CA and compatible with the UML or SysML norms. And then the idea of the Papyrus is to create the use case inside, like you can see in the screen captures. It's it's compatible, of course, with the SysML 1.6. And then the SysML profile is sent to the Studio4Education environment software. As you can see, it's something like that, with the block on the center, and then on the right the translation into the C language. And so the last part is the use of the STboard to prototype sensors and actuators on the Nucleo STM32 basement, like this. And the demonstration you will see is the use case with this Nucleo shield with the humidity and temperature sensor. More specifically, this is how is it put together, the shield on the STM board, and then these are the sensors you can see on the right that will be that will send data And then we will monitor data thanks to the Studio for Education and the Node-RED software port to see a dashboard on the end of the demo.
In Studio for Education, we are using three tools: Papyrus, Blockly, and STM32 development environment. These three tools are connected together using the Arrowhead framework. So we are using Papyrus for the requirement and functional design of an application. We are using Blockly for the procurement and the engineering of this application that has been designed in Papyrus. And then STM32 development environment are used for the deployment and the commissioning of the application. So here you can see the model of a use case, which is a home automation system, a simple one. This model has been designed in Papyrus using the SysML modeling language and the Arrowhead SysML profile. So from this model, a professor will generate a configuration file that will be uploaded to the Arrowhead framework, to the Arrowhead local cloud, and then students can download this file from the Arrowhead local cloud. So Papyrus and Blockly are able to communicate together using the Arrowhead framework. Here you can see the model that is in Papyrus and that has been designed by the professor. From this model, we are going to generate the configuration file that will initialize the palette in Blockly, and then also we are going to generate some open API code for each provided and required service in the application. So to generate the code, we need to go to the model, to the root of the model, right click on the root of the model, and then go to the designer, generate code, and click on generate code. And here we select the Arrowhead Open API option. And as you can see here, we are going to generate the OpenAPI files, YAML files, for each provided and required service of the model, of the functional model that we have designed in Papyrus. And from this OpenAPI YAML files, we can generate Java code that can run in Arrowhead framework. Okay, here you can see the generated code in the API gen folder. So all the OpenAPI files are in the Studio for Education Arrowhead model folder, and you can see the description of the services here. So the clients are the provided services, and then here you can see the configuration file that will be sent to Blockly. And from this configuration file, the student can build the application and develop all the blocks that have been defined in the functional model in Papyrus. Here we are testing the service, the Papyrus service that has been developed for the connection of Papyrus to Arrowhead. And as you can see here, the download file is executed and there is no existing files in the Arrowhead local cloud. Now we go back to Papyrus and then we right click on the file that we want to upload to the Arrowhead local cloud. And if we try again the rest query. Here we can see that we have a file now that is uploaded to the Arrowhead local cloud. And this file is the configuration file that students using Blockly can download it. And by this way, Papyrus and Blockly can communicate together using the Arrowhead local cloud. So this is the JSON file that is generated from Papyrus. And then students will connect to the Arrowhead local cloud as a consumer and then will upload the file that was provided by Papyrus, the configuration file provided by Papyrus.
Now let's see the students' parts. So when they launch the Studio4Education, they start with all the different blocks we can see on sensors or actuators. The aim of this software is to help to create, so it provides a lot of blocks and then it will be enhanced by time. Then we can choose which category we would like to see and use. As you can see, you have only to check or uncheck, and to simplify the method, the students have to download through Arrowhead framework the Papyrus file configuration. So these are the different control panel to configure everything, but it can also be configured by the teacher. And for Papyrus, the only thing teachers have to send to students is the ID registered in Arrowhead and the name of the configuration file. So after we have something quite automatic, which verify with the ping if the services and the different servers are okay and launch orchestration, etc. And then the students only have to launch the file download and it relaunch the application with everything's okay. Now let's see a real use case I already test with an ESP board and sensors. If I try to load a save file, it doesn't work because the first thing it needs is to define the board, and then if you load again the file, you will see that everything is okay. So it's not a bug. In fact, this is a choice. The first thing to decide if the board and the type of microcontroller you will program. And then the second part is to load the file, as you can see with different Arrowhead block using the Arrowhead ESP library created by Svetlin. So in my example, you could see that different kind of blocks and different kind of information could help to create the program and then to send it to the board. As you can see, when you modify something, it's automatic. Of course, it's real time. And if you want to have details of what you can do, you have the debug information on the bottom. So the first step is to install the right compiler. As you can see, it says that for the ESP we have no platform. So I update the list from the official Arduino CLI and I search for the platform for the ESP and ask for the CLI to download my platform. So when it's done, because it takes a few time, when it's done, it could be able now to verify thanks to the compiler, and it verifies the code. But of course, it's not finished. You have to do the same with the libraries and verify which libraries you have to implement. In this case, of course, the Arrowhead ESP is not known by the Arduino CLI library. So we have to put it by ourselves. You have to copy it in the right folder. So when it's inside at the right folder in the sketchbook, you can launch again. and it's not finished, of course, because my code needs a different library. So you have to do the same, verify if the library exists, if you can download it. You have to choose the right one. Just copy the official name of the library and ask to the CLI to download it and install in the right folder. As you can see, in the sketchbook libraries folder, we have now the libraries downloaded, so you can do in manual or automatic way, no problem, and so on with all the different libraries. When the verification of code is okay, all you have to do now is verify if the board is of course connected, before uploading. There is an automatic COM port detection, and then you ask for the download on the board. Of course, the compiling method could take many minutes. It depends of the board and the sketch and the libraries. So when it's done, you have the green message to tell you that everything is okay, and then the program is compiled in memory. So as you can see in this diagram, we have the complete toolchain. The Papyrus provides configuration through Arrowhead, and then the Studio4Education, which is based on the Electron Node.js to visualize and then to launch a different server. The Node.js consumes the JSON configuration file, and then the student has its environment. Yeah, we said that it's use of Node.js because, as you can see, the core of Studio4Education is made of HTML and JavaScript file, so you can test on your browser, as you can see in this example. But if it works on the browser, the limit is that you cannot use the board and cannot communicate with specific materials on your computer. So as you can see, even if you choose your board, you can prepare the program, but you cannot communicate and you cannot send, because if you want to access to the communication port, it's not possible, of course. The use of the aim of the web browser is to protect your computer. So the Studio4Education core is embedded into Electron, as you can see, and then, like any software, it can communicate with your sensor or actuators. So after selecting what you want, because it's an environment that, as I explained, is able to translate algorithms into code. So the interface is developed to be very usable and have many functions that based on the IoT. It's a software with a lot of functionalities, as you will see in this example. So I would like the board to communicate with my computer, so I start with the serial communication. As you can see, we are preparing the program for the board. What we want is to use the program on the right window to be uploaded in the microcontroller, and this way the microcontroller send data to the USB port, the USB cable, and communicate to send back onboard temperature. So the toolchain is complete. We have the compiler integrate with the Studio4Education, and then if I open the serial monitor, I can communicate with the board. So I need, of course, the same speed communication, as you can see in this example. And then so the board send me data, and I know that it get back to 25 degrees Celsius. As you can see, it's only for prototyping. Now, if you want more information, we will need something more specific. So in this example, we will use a specific block to stack information. So after verifying that it works, like I did, I will try to get all information from the board. So the nuclear board is made with different sensor, and so you can select whatever you want to environment. So now in this example, as you can see, we have the comma separation with two datas. So it cannot be visualized thanks with this simple serial communication. We need something more complex or technical. So as you can see in this example, I will prepare in fact a kind of specific configuration with information, textual and data, numeric data. Okay, so I send the information now this to the Node-RED server. In fact, Node-RED is a graphical framework created to specifically to send and get data in flows. It's not the same. How can I explain? It's not the same use of the Blockly framework. In fact, in the Blockly, you're creating an algorithm, um, something simple, very linear information. The use of the Node-RED is something more in flows, and then to see information that are transformed. Um, so now the microcontroller can send information to the COM port, and then I use Node-RED to visualize in real time what I have in the debug information. I deploy, and then it's the Node-RED server is communicating with the board, and then with this software I will try to visualize and then create a dashboard. So this new program will be uploaded to the board, and then you will see in real time in the Node-RED servers that we have the new information. And then we are creating a dashboard. Node-RED is very, how can I say, it's a very flexible programming language with a lot of nodes uh, to transform information and use it. So now I'll try to split the information from the serial port into one for the specific to temperatures, and then send in a specific visualization graph, and then split with the humidity information that will be sent to another graph, and then we will try to create a total dashboard. So as you can see, this is JavaScript that can be used inside the Node-RED and send information or to actuators or split or whatever you want with the sensor data. So in my example, um, I'll take information from the payload, so it's what you see on the right, and split the different datas. So of course this part cannot be created by the students. In fact, this way you can create a specific flow. A flow in Node-RED is a program with different nodes. So what you see in this use case can be saved and opened by the students. So what you will see in the next minutes will be all can be saved and can be reusable. So this kind of programming can be used by totally newbies, beginners inside, or you can ask to someone to prototype, and then verify if a student is able to program this kind of use case. So in this one, I would like to split information. So I send into outputs. So I need to add second outputs of the nodes, not block but nodes this time. So I'll verify into the debug window if information are split. So each time you have to deploy. In fact, it's like compiling in the Node-RED server. And so as you can see on the right, I can get the humidity percent by the low output, and on the height output I only have the data for the temperature. So now I only have to send data to the charts, and the next step will be to create the dashboard. So everything is configurable. You can set everything on your nodes. So I prepared the temperature charts that will be in the dashboard sensors data UE. Okay, so it's ready, as you can see, with the blue circle. So inside the groups named sensors data UE, we will add the humidity sensor gauge. So the two are ready, so I deploy this and to verify if it works. Now the dashboard is created, and then you can see on the right that you can configure what you want and visualize information. So the dashboard is created in real time thanks to the information we set it. And now we are changing the layout because it's not very usable this way. So the different charts cannot be changed because we have not they are too huge, and so this you have to set up the size of each graph, and then it will be able to we will be able to change the size of the layout and then what we want and where we want it. Okay, now we will see the next dashboards of our IoT use case, and then you created the dashboard with where you can see the different temperatures and the percent humidity sent by the sensors on the board. But as I explained, Node-RED is a server. It's so if you send the IP address on the board, in this use case, every student can connect to your server and send data in real time. So this way, the teacher can connect to the students' dashboard, or the students can connect to the teacher dashboard and see in real time this way.